So suppose you have been given a image. Okay, so I have given here the 3-bit image. The maximum gray level is 7. So it is a 3-bit image. Assuming the seed value of 6, segment the following image using 8 connectivity and threshold is equal to 3. That is the similarity threshold is equal to 3. And you have to also tell how many segments are identified by this particular algorithm. Okay. So in such problems, you will be given the image, then you will be given the seed value, because region growing algorithm requires the seed value. Okay, so there are two types of region growing segmentation, one in which seed is given and one in which seed is not given. So here we'll see the case in which the seed value is given. So seed value is the gray level 6, right? So this will be one requirement. We need the seed value. Second thing we need is the similarity criteria. Okay, so when we will say that the pixels are similar and they can be grouped together. So here the criteria is that the seed value, absolute of seed value minus pixel value is less than 3. Okay, so 3 is our threshold, right? So this is the threshold, and then you have to say how many segments are identified. Okay. So what we'll do first is that we will apply the threshold and threshold the image. Okay, so that we know which pixels are similar and which pixels are dissimilar. Okay, so what you have to do here is that you have to apply this formula on each and every pixel, right? So if you take, for example, 2, so we'll see that the 2 minus seed value is what? It is 6, and the pixel value here is 2. So 6 minus 2 is 4. So absolute of 4 is less than 3. No, it is not less than 3. That means the pixels are not similar. So here it will come as a 0. Okay. So this is the 0, that is, it is a false. 0 means false, 1 means true. So this is 0 we have written here, right? Then like say 2, here also it will result in 0. Now let us take this 7. Okay. So what is the pixel value? Pixel value is 7. So seed value is 6. 6 minus 7 is minus 1, and absolute of minus 1 is 1. So 1 is less than 3. Yes, means we are marking it as 1. So what we are doing is that pixels which are similar to this seed pixel, okay, it will show it as 1, and pixels which are dissimilar with the seed pixels will be marked as 0. So if you do this on the pixels, okay, then you will see that this image is segmented. Now what I have done, this is an Excel sheet, and I have just, for calculation purposes, I have directly put in the formula. You can see here what I have written here: integer of absolute of this seed value. Okay, this is $B$7 because this is a value which doesn't change, minus A8. Okay, A8. So this is the value, whatever it is, and then it is a less than 3. Okay, so it will convert. This expression is a logical expression. It will result in true or false, and I am converting that to integer to indicate it as a 0 or 1. So 0 means wherever you see here 0, it means it is a false, condition is false. 1 means condition is true. So I have applied the formula on all the pixels. Of course, you can do it manually. It's very easy. Just for explaining, I have marked it like this. Okay. So this is one first step we have done. We have applied the threshold and we have got the image of zeros and ones. Now we have to grow the regions. So that means these pixels are similar. So here you are getting 1 1 means what? These pixels are similar pixels, and these pixels are similar pixels, in the sense that they are having the intensity dissimilar to the seed pixel, and these pixels are having intensity similar to the seed pixel. That's why they are 1. So this, now we have to identify how many number of different segments are connected, created here, right? Now, what is the definition of region or segment? Okay, in a segmentation procedure. So there are two criteria for the region. To call a particular set of pixels as a region. Okay, firstly, that suppose you say that this is set of all the ones. Do they form a region? So there are two conditions. Or suppose I say that these pixels, set of pixels, suppose this 1 2 2, do they form a region? So there are two conditions. One is that they must be having the similar intensity. That is the first criteria. Similar means what? Their difference should be less than 3. Here the condition is given. So now if you take these 3 pixels, their difference is less than 3. Okay, so one criteria is satisfied. Now another criteria is that do they satisfy the 8 connectivity criteria? Are these pixels 8 connected? Suppose you take this pixel, okay, and then the next pixel is 2, so which is similar to this pixel. So they will form the group only when they are connected. Okay. Now you can see that they are 8 connected. Okay. So they are connected to each other. Now then they will be forming a region will grow. Now this will be the region, right? Now next, suppose you take this pixel. Is it similar to this? Yes, it is similar because the difference is less than 3. Now this pixel will be attached to this segment. Why? Because it is 8 connected with this region, right? So this one is 8 connected with this region. Okay, just if you go in a this is a neighbor, 8 neighbor of this, right? So we say that it is 8, and also 8 connected means it is 8 neighbor as well as it is having the similar intensity. So then this will form a segment. Now, okay, this is 1, 2, 2. Okay, these are similar pixels. Now, these are also similar pixels, 2, 1, 2. Now, can this segment be joined with this segment? They cannot be joined because there is no connectivity between this segment and this segment. Okay, so they will form a different region, although they are having the similar intensities. Okay, these pixels are having similar intensities, but they do not form a single region because these two regions are not connected. Okay, so like that we have to find out. Okay, so now let us do the labeling procedure here on this. So let us start from this pixel 0. So this is the first pixel, so we'll give it a label as A. So actually what is segmentation? Segmentation means what? Labeling each pixel in the image, whether it belongs to region A, region B, region C, region D, region E, region F, whatever it is. So we have given taken the alphabetical labels now. Okay, so every region will get some label. So let us start with this. Okay, 0. Now is it okay? So this is a labeled as A, the first pixel, right? Now the next pixel A. So it is similar to this pixel. Okay, and is it 8 connected? Yes, it is 8 connected. So this will also get the label as A. Now we'll move on. So we are moving from left to right and from top to bottom. Okay. So this is the first. So this will also get a label, same label A because it is connected. Okay. Now let us take B. Now is B similar? Now this is the take this pixel 1. Okay. Okay. So our procedure is not completed, right? So I have, although I have written it here, complete thing, but I will tell you we are moving from here to here, and now we have moved to this particular place. Okay. So what about this? Uh, is it similar to this? No. So that means it will take another label. So let us call that label as a B. So it will get a new label B because it is not similar to A. Okay, this one is not similar to 0. Okay, so it is new label has been there, B. Okay, now let us take another label C. Let us move to next pixel. So it is 0. Now is it similar to earlier one? Yes, it is similar to this, that is similar to A, but it is not connected. Okay, because there is one in between. 0 is not connected to this 0. So that means here the new label will start. So this C is a new label. Now is this similar to this? Yes, so it will carry the same label. Again you will go to the next row. Again we'll come to this. So this is 0. Okay, so 0 is already there as a label A. So is it similar to, so it is similar to this. Is it connected to this? 8 connected? Yes, it is 8 connected. So it is same, carry same label A. Now let us go to 1. Now is it similar to the earlier label? Yes, it is similar to this label B because this B was also 1. So now is it connected with this? Sorry, is it connected with earlier uh, 1? So is it connected to 1 here because we have reached to this point? Okay, so is it connected to this? Yes, it is connected. It connected. So this will again get the same level as that of this. Again you can see that this is connected, so and 1, so it is B. This is connected and also 1, so it is B. Now we are reaching here, it is 0. Now 0 is also earlier occurring, so here it is occurring, right? So is it similar to this? Yes. Is it connected to this? Yes. So it is carrying the label C, right? So like that you have to move from row to row, row by row, and you have to label each pixel, right? Now here also you are having the same labels B, 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 and it is also connected, so it will get the label B. Now when you come to this place, see here, when you come to this place, Now why it is getting new label? Because you can see this 0 is already there as A. Okay. So, but is it connected to this A, this particular pixel? This and this is not connected because there is in between, or there is 1. Okay. So it is not connected. Even you can connect it to this, but there is a 1 in between. Okay. So this is now become a new label. So this new label will start as D. Okay. So then again we'll move to next pixel B. Is it similar to earlier label? Yes, it is similar to B. It is same as B. And is it connected? Yes. So it will also get the B. So like that, this is connected as well as having same as 1. So this will be B. Now come to this point. It is 0. So 0 is occurring earlier also. But is it here? It is as A, and here it is at B, and here it is at D. So is it connected to A, C, or D? Neither this, nor this, nor this. This is not connected because there are ones in between. So that means you have to start a new label E. Okay, so this is new label E. Again, this is 0. So 0 is connected to this, same as this, and connected. So it is D. This is also 0 and it is connected. So it is D. Now this is B. It is same as 1. So it is connected to earlier B. So it is labeled as B. Then this is E, which is, so this is 0. So it is similar connected to 8 connected to this. So this also becomes C, and it is connected to this. So this also becomes E. Okay. So that means now how many segments you are getting. So this AA mark is one segment. CC mark is second segment. BBB mark is third segment. DD mark is fourth segment, and EEE mark is a fifth segment. So there are 5 different segments and they are marked with different labels. Okay. So this is how we have divided this particular image into 5 segments. Okay. So what is the step we have done? So we have been given that you have to check for similarity. You have to take this particular condition. Okay. And 8 connectivity is to be established. Okay. So that means 8 neighborhood plus you have this condition. So pixel must be in 8 neighbors if you want to connect them or you want to grow the region, and they must, their difference of absolute difference between the seed and the pixel must be less than 3. This was the criteria. So first we have applied the criteria and marked the similar pixels. Okay. So zeros and ones we have got, and then we have, according to the connectivity, we have grouped the pixels together. Okay, like you can see here, this 0, this region 000 and this region 000 should have actually got the same label. But why they are getting different labels A and C? Because they are not connected. So that's why they are different regions. So the important criteria for identifying region is that the region, all the pixels in the region must be similar in value and they must be connected to each other. Then only we can call it as a uh, region, connected region, or you can identify it as a segment. So here there are 5 segments in this particular example. Okay.